All right, philosophy class, welcome to 2.2 of Modal Logic. We'll be talking about semantic validity in this and the next lesson, and hopefully we're going to be making a lot more sense of that relation that we were talking about. And we'll be talking about the truth conditions. Now, you'll notice here from 1 through 5, they look exactly like the propositional calculus look like. So not A is true if A is false, something like that, right? But then you'll see these little W's. Now, what those W's are, they're indexing the truth values to a world. And what that means is in world W, not A is true if in world W, A is false, which is pretty much the exact same thing we did in propositional calculus. So these W's really don't make a difference for 1 through 5. What they do make a difference for is in 6 and 7. And in 6 and 7, we're going to see two different indexes. And that's why they're going to make a difference. So this first 6 here says, possibly A is true at world W if there's some other world, W prime, that W is related to, and in that other world, A is true. So possibly A is true in W if it's related to some other world where A is true. So let's say A is that ice cream is delicious. We're going to say, and a W will be our world. It's possibly true that ice cream is delicious if there's some other world where we're related to, and in that world, ice cream is delicious. That's what that means. And if there's no world that we're related to where that's the case, then it's false. That possibly ice cream is delicious, this is false. This down here says necessarily A. So at our world, necessarily A is true if for all worlds in which we're related to, in which W is related to W prime, A is true at W prime. So ice cream is delicious is necessarily true in our world if all worlds where we are related to, ice cream is delicious, and it's false otherwise. What do I mean, of course, by related to? That's the big question, and it's a little hard to see. I can show you on this picture how we're going to depict relations, at least pictorially. Here's how I'm going to have these arrows depicting W is related to W2 and W is related to W3. But what does it mean to be related to a world? Well, that kind of means that from our world, it seems like these are the possibilities. Now, maybe there's some W4 that we're not related to. So what that would mean is whatever is true here, let's say A is true, maybe A is false, I don't know, it wouldn't really matter. Whatever is true here, from our world, this is not an accessible world. It doesn't seem like this world is a possibility. And if this world doesn't seem like a possibility from our world, then it doesn't matter what's true or false in this world when it comes to these possibly A's and necessarily A's. That doesn't matter because this guy, we don't access this guy, so it has nothing to do with us. So from our world, something is possibly true if it's true at a world that we access, and it's necessarily true if it's true at all worlds that we access. And if there's some world that we don't access, we don't have to worry about those worlds. You may wonder, so what would it be like to have a world that is not possible from our perspective? It's kind of hard for me to even come up with a world like that. Usually that is for other modal logic systems where this becomes a problem. But we're not going to talk about those, so really that's not going to make a whole lot of sense. Just, that's what the relation is. The relation means from our stance, these are the possible worlds. These are the worlds that we can access. From our stance, this is not a possible world that we can access. So maybe it is possible, but not from our perspective. Okay, so forgetting that, and this truth statement, what does it mean? What is this truth condition? Well, possibly A is true if there's some world that W is related to, so this is W, there's some world that W is related to in which A is 1. So from this world, it's related to two different worlds, and one of those worlds, A is true. Notice that one of the worlds A is false. That's okay. I don't really care about that. I'm just worried about at least one of the worlds that W is related to is A true. And if that's the case, then it's possibly true. Possibly A is true. So we could write possibly A here if we wanted to. Notice that W2 is not related to W, and W3 is not related to W. Right? W is related to these two, but they're not related back to them. What does that mean? That would mean that from W, it seems like W2 is possible, but W2 is not, from W2, W is not a possible, it doesn't access W. Whatever that looks like isn't really important. W also, notice, now this is going to sound really weird, but notice W does not access itself here, right? So from W, W doesn't access itself. It's not related to itself, in other words. That seems like a little bit, that seems even harder to understand. We're not doing some other modal systems, but in other modal systems, that would be it would make sense why W couldn't relate to itself. But it would be kind of hard to understand, like, let's say ice cream is delicious in our world. Doesn't that mean it's possibly true that ice cream is delicious? Yeah, that seems right. So yeah, in the modal logic we're going to be dealing with, our worlds are probably going to access themselves. And here's what it looks like when a world accesses itself. And if W accesses itself and A is true in W, then possibly A is true, right? So notice I have in this truth condition, W prime is a member of W such that the world W is related to W prime. Well, here I show that W prime could equal W, right? So if W prime is W, that's okay. W R W would be the way we would see it. W is related to W, and in W, the truth value of A is 1. So the truth value in W of possibly A is 1. Even if W is the only possible world, the only world that it's related to. Here's a case where possibly A is false. If there is no world that W is related to in which A is true. Right? So there is a world where A is true, but W doesn't relate to that world. So it's not accessible to W. So in all the worlds where W can access, is related to, A is not true, so possibly A is not true at all. That's true even if the world in which A is true relates to W, by the way. It says W must be related to W3, but W3 can be related to W without this happening, without possibly A being true. Alright? So W can access W3 even if W3 can access W. If it said this, if we had a double arrow, right, W3 accesses W and W accesses W3, then we would have possibly A equals true. But since we don't have that, it doesn't work. Alright, here, notice A is true in all of the worlds. However, W doesn't access any of those worlds. So there is not some world that W accesses in which A is true. So possibly A is false here. That sounds really weird, right? A is true in all of the worlds, but if there's no access to any of these worlds, if we don't have any of that stuff, then possibly A is not true. So of course now you can see if W doesn't relate to any world, then possibly anything is always going to be false. It has to access at least some world for possibly anything to be true. Necessarily, let's go to the necessarily truth conditions. Necessarily A equals 1 if for all worlds that W relates to, A equals 1. So here we have the same setup as the initial one, except for A is true in both of these worlds that W accesses, so necessarily A is true, right? When I look at all the worlds that W accesses, A is true in all those worlds, so necessarily A is true. Notice I don't have A in here, right? It doesn't matter because W doesn't access itself in this picture. So necessarily A can be true even if A isn't true in W, in the world that you're worried about. You're just worried about the worlds that W can access. Is A true in those worlds? Here you have A being false in a world, but since W doesn't access that world, you're not worried about this world. You're worried about all the worlds that W accesses. Is A true in all those worlds? Now, it may seem bizarre when you look at this and you say, but if not A is true in some world, doesn't it seem like, well, maybe it does. Maybe it is the case that W has to be related to W2, maybe, but if it's not, then you're not worried about that world. And of course, that's also true if W2 relates to W1. It doesn't matter if W2 relates to W1. W has to relate to W2 in order for this to make any difference. Okay, here's a case where not A is false, not A is true in the same world that you're talking about, in W. But since all the worlds that W is related to have A true, then necessarily A is also true. Here's a case where necessarily A is false. There's a world where W relates to where A is false. All right, so since there's some world that W relates to where A is false, necessarily A is false. And now here's that one where W is related to these two worlds where the A is true. But now since W relates to itself and A is false in W, then necessarily A is false. Now here's an interesting situation. A is false at all worlds, right? But W does not access any world in this scenario. So look at the rule here. Necessarily A is true if for all worlds that W relates to, A is true. Since there are no worlds where W relates to, it is true that for all worlds where W relates to, A is true, right? Since there are no worlds where it's false. So since that's the case, since it accesses no worlds, necessarily A is true. And you can imagine, you could fill this out with B and C and whatever you want. Necessarily B would be true. Anything you want is necessarily true at a world that doesn't access any other worlds. Seems totally bizarre, right? So probably there is no world that doesn't relate to some other world. That's what that probably means. But that's the way the logic works out. And that's the end of this slideshow.